Good morning, everybody. This is the captain speaking. Yes. And this is now totally done. I've got the belt tensioners on there, and I got the thing so that I can spin it by hand here. You can see the flywheel spinning. I got that shimmed and gooped. I've got a Dremel tool the excess shims off, and all four ECMs are turning. I'm waiting on goop on a couple of places to dry. I got about another 20 hours to wait, and then I can fire the whole thing up. Each of the four ECMs has got AC to DC power supply, and I've got some on each of them. I've got some bleeder resistors. Not sure what the voltage is. At 200 RPMs, it puts out about 40 volts AC, peak to peak, whatever. And so you can see it took a long time. It took over a day to shim the damn thing. But anyway, so this is the controller board that I had sent to Tim with the IRAMS part on it, and I got that working, but I've got to swap that out. One of the IRAMS pins is just barely connected. These three sections, 1, 2, and 3, are still the pickup coils. Now the pickup coil energy is processed by these two FETs over here. One allows this cap to charge, and then it disconnects the cap from the pickup coils, and then this FET over here allows the cap to discharge into whatever. And I've got 100 volts so far on each of the pickup coils. There's some timing parts down in here, and an inverter, and all this crap, some bridge rectifiers, whatever. And so the system I'm going to have, I've got a capacitor bank set up here for 12 volts. I don't know, it's about 40 farad when it's all added up. And I've got a pure sine wave inverter down here. That's I'm not sure what the hell the part number is. I guess I don't know if you can read that or not. But it's an Ames power, made by Ames, 12 volt to 120 60 cycle, pure sine wave. And got the Variac here. This was another board I bought, controller. I had my Hall sensors were way out of whack, way out of the position. Even though it was running very smooth, there's some kind of relationship between, so this is the power supply and all this crap to run this, and then this connects to the Samsung motor. Anyway, what I found was this, the Hall sensors, I had to go back to my, here they are down in here, they were way over here because it was a lot easier for me to handle them. And but I had to go back to my original video 148, Don Smith number 148, and went through that and to figure out exactly where to put them, because I was getting some serious RPMs with no load. Just to bring you through this lab. This is the Jack Schultz rodent coil test with a magnet spinning in there. That all's proven. This whole assembly here is a Tesla hairpin circuit with a spark gap. Then I used a picture frame clamp, half of it I used just a hacksaw, cut it off. So this is all adjustable spark gap. The high voltage comes out through the caps. Then that actually drives, I don't know if you can see them, but way in the back up there, there's a couple of golden ratio antennas. This assembly here is the driver for the anti-gravity platform. I have never fired it up. I need to do three energy systems with a level of 4, 10, and 17 to go in and see what the pyramids will do. And so that's some of the crap I built. And this is down here is the impulse motor for the car. That actually runs. It only does about 40 RPMs, The original one is way in the back over there. That one did 400, I think, was the most I ever got out of that. But I need to get back into that sometime too. And this was my own FET driver connected to an old IRAMS board, and the FETs would fry a lot, and I think that's because the Hall sensors weren't in the right position. So anyway, there you have it, and we're getting real close to fire this whole system up. Have a good day.